we do a lunar calibration, it's once a month, and we do the maneuver only at nighttime, or basically when the spacecraft is at nighttime, so we don't have to worry about the sun hitting the spacecraft someplace we don't want it to hit. So we do all our maneuvering in the dark. We'll take the instrument and we'll point it away from the Earth, and we'll basically point it up at the moon.
Around the time you enter eclipse, the slew is starting. The spacecraft is maneuvering to point to the moon. It slews out to the moon, and it stands by there for just a short time until it starts the scans.
It's a push broom instrument, so it basically consists of like 7,000 detectors that build up an image of the Earth like you'd push a broom along the surface. The actual focal plane is made up of a number of modules. There's actually 14 modules across the focal plane. Each one has about 500 detectors.
And the spacecraft has to take each one and run it down the same center line in the moon.
Our scan pattern is a lot like just how a farmer would plow the field. You plow down the field one way, turn around, and move over and come back.
It basically moves the spacecraft so that each one sees exactly the same field of view across the moon.
We actually do this over a period of 2 orbits because we don't have enough time in one orbit to get all 14 focal plane modules.
That takes about 18 minutes for 8 scans, and then it will return back to Earth just as we're entering daylight. And then the second orbit will do the rest of them.
The main reason we look at it is because the moon is a stable source. It doesn't have any seasons, it doesn't have any rain to change the soil color or anything like that, so it's as stable a thing as we can find. By looking at the moon, we can see drifts in the instrument much more precisely than any other technique that we have. So that if you're looking at something changing on the Earth, you know that it's really the Earth changing and not the instrument.